today, as we are soon ending our solar installation topics, we started from the solar panel, we went on solar charge controllers or regulators, then we went on solar batteries. On solar batteries, again we are going to go for inverters. Okay, now I wanted to combine what we have started from the beginning, from the solar panels, the regulators, and the batteries. We want to see how to connect these components, the solar components. Okay, now today we are going to do the solar wiring diagram. The solar wiring diagram, it shows how you combine your solar panels, your regulators, and the battery plus the inverter. How do you connect them to do the complete solar wiring? Okay, for the technicians, electricians, and solar engineers, this topic is best for you people. Okay, now let us start. Let's try to name them. This is our solar panel. Let's say solar panel. This is our, we call this circuit breaker. Circuit breakers or fuse. You can call them fuses. This is our regulator. Let me change this. We call this regulator. Then these are fuse or circuit breaker. Then we say this is our battery. This is our inverter. This is from a regulator. This is a DC load. A DC load or loads, because they represent DC loads, sockets, lamps, security lights, indoor lights. We are putting this as to show that these are the loads which are supplied, which are DC. Okay, now from the inverter we shall also have the output, which is AC loads. AC loads. Okay, now before we go far, let us try to see how do we connect a solar panel with a charge controller. How do we connect a charge controller with a battery? How do we connect a battery with an inverter? Then you can supply on our appliances from inverter to the appliances, that is AC. If we talk about the inverters, we shall come up on the topics about inverters, because when we talk about inverters, we mean we are inverting DC to AC, direct current to alternative current. Okay, that is AC, alternative current which shocks. Okay, now let us start with the solar panel. A solar panel we have, as a technician, let me explain technically. Get your solar panel, talk to the client, size your solar panel. If you didn't master how to size a solar panel, please go to the previous videos, then you will see how to size a solar panel. Okay, according to the client's loads, it will give you the solar panel you need, and you calculate the regulator you need according to the wattage or the appliances the customer is going to use. Then you can also go and check the video about the calculations of the battery sizing. Okay, battery sizing, you calculate the ampere hours, okay, according to the loads of the customer, because you calculate the time, the time for charging and the time for discharging and the wattage hour of the customer's appliances. Then it will give you the solar panel sizing, then it will give you the regulator sizing, then it will give you the battery sizing, and we shall see how you calculate for the inverter sizing. okay? Because the next topics are going to based on inverter sizing. Then we after covering everything, then we shall cover also the faults, the solar faults, all faults concerning solar system. So faults in the solar panel, faults in the regulator, faults on the battery, faults on the inverter, so faults on the loads. So we shall see how to solve those problems, okay? After finishing the inverter. Now let us start with the solar panel. Let us say our client we have sized. Let us say we have sized. Let me use green. Let us say we have sized a solar panel of how many watts? Let us say 100 watts. Okay? Our solar panel has, this is not clear. Our solar panel has 100 watts. Has 100 watts. Let me use black. Has 100 watts. Our solar panel has 100 watts. Okay? Now you're a technician or electrician. You have bought for the client a solar panel of 100 wattage. You went on, you need to install these components in a solar. Either a customer may be having a store or some space. First look for a space in the house where you're going to install all your things. The fuses, the regulator, the battery, the inverter. All where you're going to put your things in a safe way, where people are not moving. Okay? Because someone may be moving and by mistake he removes a terminal from the battery. So you need to install them where people are not really going there. Okay? Now let us start with our solar panel. We said you have calculated that a client needs a 100 watt panel. Okay, we have bought a 100 panel. Then we went on. Before you connect the solar panel to the regulator, please install a fuse or circuit breakers. One side for positive, another side for negative. Okay, because once you install the solar panel on the roof, these terminals will send the DC. Let us say it will send, normally these panels, they have, they can send, if it's going to charge our 12 volt battery, 12 volt battery, let us say it's going to charge our 12 volt battery 70 Ah. Now this panel will send, I think it will be like 21 volts, 19 volts to 21 volts. It depends on the area on the amount of sun you're receiving. It may be sending 21 volts maximum power. Then you need to put your circuit breakers before you terminate, before you connect them to the regulator. Okay? Put your circuit breakers to avoid shocks when you're terminating. Okay? Because solar panel is the last part to install on a solar system. Okay? Here it is the first part we are using to drive our diagram, but technically it is the last, or logically it is the last component in solar system to be installed, because of it will be producing voltages whereby you can get shocks or burn. Okay? You may burn your regulator, you might burn your inverter. You can make some slight mistake in terms of connection and you end up losing your expensive regulator or charge controller. Okay? Even the battery. The time of terminating when this one is producing, the solar panel is producing power, you may damage the cells inside the battery. But we shall see all these faults when we come on fault finding or fault solutions on all solar system components. Okay? Now, put your fuses, circuit breakers, terminate, like screw your panel after installing it. Put a circuit breaker. A circuit breaker may be with two terminals, okay? One terminal for positive, another terminal for negative. Then install your, see the distance from here to here. It's not long, like from the roof. Use one side. Put all your components near to each other, okay? Put your breakers near to the circuit breaker so that you don't put a long cable for in case. Remember we saw about the bills, I mean the losses, cable losses. If the cable is too long and you're terminating from here, it is too long, like some meters away, we shall have some voltage losses in the cable, whereby it needs to be near this circuit breaker, needs to be near the charge controller, and the charge controller needs to be near the circuit breakers, which are all the fuses which are going to the battery, okay? Because on the battery, we shall see the inverter is connected on the battery. Now let us go back here. After connecting your fuses, then terminate or switch off the solar panel fuses, the circuit breakers, trip off. Then you can do this remaining part. Meaning, if you are finished to install a solar panel, the voltages will end here on the fuses, okay, or on the circuit breakers, those voltages from the panel. Meaning, you can install your charge controller, you can install the DC loads. These are the DC loads from the charge controller. DC loads, I mean the wiring, the house wiring, okay? Even the AC loads, I mean the house loads. That is the socket, you put on your switch. We shall see this when we reach in electricals, how to wire a switch, how to wire a socket, okay? Because they have the same principles. Those are the loads, I mean. Your solar bulbs, your switch, the sockets, okay? The fridges, all will fall on the loads. AC loads, DC loads. Now, after installing your regulator, install the battery. Put the battery very well in the position firm. Tighten the terminals on the battery terminal. Tighten them with a screwdriver or this is it called a clamp, okay? Then connect the battery to the inverter. Inverter is not connected on the regulator. Inverter is connected on the battery terminals. That's when you're connecting an inverter. When you're connecting an inverter, connect on the battery terminals direct, not on the regulator. Regulator has small holes to fix your battery. There is no way, because on the regulator they show terminals from the panel, terminals from the battery, and terminals to the loads, but they have not indicated terminals to the inverter, meaning you don't connect direct on the inverter, on the charge regulator. At least some regulators have those terminations, okay? That space for inverter termination. Or even some regulators, there are some regulators inverter charger, which they are called inverter chargers, meaning it is an inverter charger. Inverter charger means it is an inverter with a regulator in it, inbuilt, which is 2-in-1. Inverter charger, which means it has a regulator or inverter regulator. But the best word is inverter charger. It can charge and it can discharge the battery, okay? That is used when you're using on the grid. When you're using on electricity, you may not buy your solar panel, and you just buy an inverter which has 2-in-1 inbuilt inverter charger. When the power goes, the inverter converts the DC into AC, then power comes. Then when power comes, the grid comes back. The inverter, it does it automatic. It removes, disconnects, then it starts charging the battery. That is the inverter charger. Now, you might have the inverter charger to charge your battery. But if this inverter is not automatic or it is not inverter charger, then you are forced to put a regulator to charge your battery. Do not put your solar panel direct to the battery. Always use a regulator. Okay? Without a regulator, your battery, the power from the inverter, from the solar panel, power may come too high. As I said, it may produce 21 volts. Okay? Yet our battery may need 15 volts. Meaning, if we put the 21 volts come into a regulator will regulate it. Okay? As its name, it regulates it and it modifies it for the battery to charge at a slow pace. And the battery will get full. Okay? Than getting your cables direct to the battery. It is not good technically. It's not good how? Because the solar panel will send high voltages to the battery and the battery will not have no control. Remember, this regulator controls, it regulates the voltages which are coming to the battery to charge slowly at a slow pace so that the battery doesn't get fault. And it indicates here, it has readings that when a battery is full, this regulator disconnects the power from the solar panel. And the solar panel, it will be done automatic. The solar panel will be disconnected inside the regulator when the battery is full. Okay? That's why we need a regulator very much. Okay? Because when you put your battery direct, the battery will consume power. It will get full and the solar panel will continue pushing electricity or pushing that DC power to charge the battery. Yet the battery is full, meaning the battery may burst, may explode. Okay? Now, which controls that? It is the regulator. The regulator will control this. And it will wait. When the battery is full, it disconnects the solar panel. That's the use of a regulator, automatic. Either you're using MPPT or PWM, they do that, automatic. And our battery will last for long. Without the regulator, the voltages from here will charge the battery will get full and no way to control the excess energy, the excess voltages from the panel. The battery will end up getting swollen on the sides. I think you have come across those batteries. We shall talk about this in fault findings and what causes the faults of the battery to die. Okay? Because of lack of or no installing a regulator. Now, on the regulator, the use of this circuit breaker is when you're going to work on this system or you're going to do some repair. Okay, you can disconnect the circuit breaker. Disconnect the circuit breaker, which brings the solar panel power. Disconnect the circuit breaker, then you can do the repair on the regulator. Okay, because you have disconnected the source. It's like in electrical, when you want to work on the installation in the ceiling, you're going to do some repair work. First of all, you first go to the meter box and disconnect from the main source. Now, this is maybe our meter box or main source. Disconnect the main source, the solar panel. Then you can work on the regulator. Then you can work on the battery. Then you can work about the wiring, the loads. Okay, the connecting of the inverter. After finishing, come here, connect on. Then you will see that solar panel is connected and there is no fault with your wiring diagram. Now here comes, what do we first connect on the solar system? The first thing is connect the loads. Okay, go and wire your solar system loads. Either you're going to use a solar DC loads. Those are lights which are going to work direct on the battery. That is DC, because the battery is a DC battery. Those are the fridges which are going to work on the DC. okay? Fridges, your bulbs, your TVs, okay? Because they use either when they have a provision of using a DC, a 12 volt, but 12 volts power supply, okay? Now, wire your house. After wiring the house, connect it to the regulator, okay? If you're going to use AC, then you apply an inverter. Apply an inverter. An inverter produces or converts the DC power which is stored in the battery. It converts it into electrical energy. Okay, this energy which is stored in the battery is stored in, it is chemical energy stored in the battery. Now the inverter changes the chemical energy which is stored in the battery. This chemical energy which is stored in the battery, the inverter inverts it or converts it into electrical energy, from chemical to electrical. Electrical, I mean, it will convert it into a DC. That is the shocking electricity. Some inverter produce something like 200, 220 volts to 240 volts. Okay. Some produce 110 volts, 110 volts. That is the output, but the input is 12 volts. Input 12 volts. Input comes here, 12 volts. Output 110 volts, 220 volts, or 240 volts. Some inverter produce AC voltage on high grids. Okay, now these are our loads, the wiring, your TVs, your lights, your fridges. Those are the loads. Okay, we are using this to represent the loads. Okay, now first connect your loads. I'm showing you how you connect this. You find final connection. After connecting the loads, know that you've connected your switches very well to the lamps or to the bulbs. You've connected your sockets very well. You've connected your fridges, your TVs, your lights very well. The termination is good. Confirm when it is good. Okay? Now, bring your termination. Instead of in electrical, we take it to the main switch. Now here, this will act as our main switch. The regulator will act as our source of main switch. Bring it to the main switch. This regulator will show you a negative terminal to the loads. Okay, they write it load. Then a positive terminal to the load. That is number one connection. When you're doing your solar connection, connect on the loads after doing your wiring. Connect the loads. Now, after connecting the loads, the second thing is to connect the batteries. Connect the battery. I have put here these fuses from the solar charge controller. Put at least fuse for protection. I say you put a circuit breaker. Put a circuit breaker for protection. Even here, it needs a circuit breaker in case you're going to do some fault findings. Then coming here and unscrewing on the regulator. Connect once. Then you can put here your fuses. Put a fuse. Okay? Circuit breaker. When the house has some faults, some bulbs are not working, you want to repair your fridge, a TV is not working, please, you can disconnect the circuit breaker. Instead of coming here on the regulator, unscrewing the terminal, and then you screw the terminal, you will weaken the strands, the wire strands. Okay? These wires which enter here, you might weaken them. The first time you have connected it firmly. Now the second time, you might also forget to connect firmly because you're playing around these terminals. Instead, put a circuit breaker, disconnect the circuit breaker, then work on the loads. Which loads? Those are your TVs, your lights, your fridges, which are connected on the DC. On the DC, which is DC, I mean, it is connected direct on the battery. This regulator, these cables are connected like direct to the battery. Unless when you're going to use an AC components. AC components, I mean, we shall bring in an inverter to convert DC to AC. And these are the loads. These are loads, the fridges which are going to work on AC, which AC I mean 220 volts, 110 volts, 240 volts. Those are the AC. Your bulbs, which are using AC, alternative current. Your TV, which are using, there you will apply some sockets, okay? But here, you will still work direct DC, but here it is alternative because of the inverter, which is inverted in to convert DC into AC. Now, after doing switch off, the same thing applies here. Here on the inverter, I've put a fuse because now here comes a main switch. A main switch, then to the loads. Main switch, we have circuit breakers, 5 amps to the lights, 15 or 20 amps to the sockets, 30 amps to the cooker control unit. That is the main switch. Because we are on the grid. The inverter has produced a grid power. Now, let's come back here. On the regulator, the next thing to connect, after connecting your loads, then connect the battery. Before connecting a solar panel. Solar panel is the last thing to connect, as I told you. But we have here circuit breakers. We have connected everything, but we have disconnected the circuit breakers. You see the use of a circuit breaker? Disconnect. Then going and untying your connections. Tying and untying. That thing causes sparks. And once in solar systems, sparks are not good. Sparks spoil these electronic gadgets, and yet they are expensive. Let us say you're using an MPPT. MPPT is more expensive. It's expensive everywhere. MPPT is expensive than the PWM. That is the type of charge controllers. Now, this spark, when you untie, you'll see when the panel is producing high voltages or high currents on a high peak sun day, you will find that we made short our, this is the electronic gadget, okay? The MPPT or PWM, we say. This we might get loose because it has components. Which component? These are the transistors, the resistors, the switching transistors inside here, the ICs to control and to monitor the battery charging and discharging. It may get fall because of the sparks. That's why we have applied the fuse here. Now, disconnect here, connect your load freely, connect your battery terminal. The thing I want you to remember, connect always negative first. Negative, the black part, negative sign. Okay? Negative, then positive. Negative, on the battery side, also connect a negative first. Okay? Connect a negative, then a positive. Once you connect a positive, you'll see your lights or your gadgets lighting. But don't disconnect here. Before you connect, remember, those are sparks. When it sees a load connected on it, here you'll see sparks. That's why we have disconnected here, we have disconnected here. Okay? Even though our cables from the load are coming, from they first come to the circuit breaker, after circuit breaker, then to the charge controller. And we shall avoid the sparks. Because this is electronic gadget, I told you it is expensive. Once these loads are connected and you didn't switch on this circuit breaker, once you connect your positive terminal, after connecting your negative terminal, after connecting your negative, positive from the loads, and you forgot to switch off this circuit breaker, the moment you connect a negative terminal, there is no effect. The moment you connect a positive terminal to the regulator, you will see an effect. Even the regulator will light up. Light will come, spark will be there because the load is connected. But if you switch off or you disconnect the load from the circuit breakers, once you connect your positive terminal, no effect will be there. the regulator only will be the one working. Okay, you see how we are doing it safely. Now, after connecting here, still you don't connect, you will see sparks. We have brought in the circuit breaker again here between the regulator and the battery. Everywhere there is a circuit breaker, switch off, connect. After finishing, confirm that it is firmly connected, then switch on. Without switching this off, without switching this on, this is off, this is off, this is off. After connecting this, then you can try and test the regulator. After connecting the regulator on the battery, now it is time to switch on your circuit breaker, which are connected to the battery, a regulator and the battery. Readings will come on the regulator. Okay, some readings will come on the regulator, and these readings will give us that a battery is connected, and this regulator will read the capacity of the battery or the voltages of the battery. If it is 12 volts, when it is full, our regulator will show us, it may show us that it is 13.44 volts on the regulator, meaning our battery is fully charged. You see how we are doing it safely? Now, after confirming that the battery is firmly connected, try to test your load. Before you test, you bring power from the panel. Switch on the circuit breaker which goes to the load and see what will happen. Be curious when you're connecting the things. Always be observant. Okay? Don't listen music. Don't think on anything. Be observant and think. Listen. You might hear some bulb blowing. Okay? But if you don't listen, you will not find that fault, that there is a short circuit somewhere. Switch on the circuit breaker. Nothing is happening. Okay? Go back to the readings on the regulator. Regulator will show you that the load is connected. It will indicate you on the screen. Some regulators have no swing, but good regulator, let us say we are using a PWM. It will show you a reading that battery is connected and a load is being connected. And then go to your loads. Try to check, is the fridge working? Is the TV working? Is the sockets working? Are lights working? Switch on the lights on, off. Test the voltages. Okay. Get your meter like this. Go to the regulator. Try to test the voltages. If they are fine, then our system is on the load side. On the load side is good. On the battery side is fine. Then, meaning we have connected very well our regulator. Now, let us test. Let us test if our battery will charge, if our regulator will charge. This means we are going here. Get your meter before you switch on the circuit breaker from the solar panel. Get your multimeter, positive, and negative. Positive, negative. See if the multimeter is going to show you the readings which you're expecting from the panel. I told you when it is disconnected, the terminals are now, meaning it is not, the voltages are not reaching here. Here you may see 21 volts at maximum power peak. When the sun is at peak, that is around 12, yes, at noon, that is the maximum, the solar panel receives the solar rays. Okay, that's when we say the solar panel, the sun rays are at peak, where your shadow is under you. When the shadow is this side, it means the sun has moved. Now, when the sun is under you. When your shadow is under you, it means the sun is direct to you, and that means it is at peak. That is the technical term in solar system. It means this panel is receiving sun rays. It is receiving sun rays. Okay? At peak. At peak, when the sun is maximum at its maximum point. Here it will give you something like 21 volts. Okay? You may measure, remember it is 100 watt panel. It may give you 21 volts after measuring with your multimeter. Now 21 volts, if you see your 21 volts here, meaning, let me connect. Remember you have finished connecting here on the regulator. Then connect on, switch on. Wow. After switching on your circuit breakers which are connected on the solar panels, now the regulator will show you that a solar panel is being connected also. You see how we have driven our connection from the loads? Connect this, then connect this. From the battery, connect this, the fuse, then connect on the regulator. From the solar panel, connect the fuses, then connect to the regulator. Now, this, you know the use of these circuit breakers we are putting in. Some people forget to put those things, but they are not expensive and they help to solve problems. When you're working on the solar panel, when you want to increase on the solar panel, or when you want to add on the solar panel, okay, you can just switch off here. The system will be working. Okay, then add on another panel, do the connection. After finishing, come and switch on here. Simply, if you want to work on the loads, you want to look for the fault on the side of the DC loads, switch off the circuit breaker. Then you can add on another bulb. After adding on another bulb, come and switch on the circuit breaker. You see, this is a DP. Use a DP because the DP has a positive and negative points. Okay. The same thing applies even here on the inverter. There is a main switch, always inverter output always pass through main switch. Okay. Now, after seeing connect on, a regulator will show you that a solar panel is being connected, and here we shall see that our system is working well. The battery is being working well here. The regulator will show you everything. That's why we say a regulator is the heart of the system, because you just come and stand on the regulator, start reading what the regulator is telling you. If there is a fault, the regulator will tell you that there is a fault. If there is a fault on the load, the regulator will disconnect everything automatic. Let us say when you're using MPPT or some types of regulators, they will disconnect automatic, and you will know that there is a fault on the side of the load. If there is a fault on the battery terminal, the regulator will indicate that there is a fault on the battery terminal. Okay, and you will say, let me first disconnect the battery. Disconnect the always don't forget, when you're doing any repair, the first thing to disconnect is the solar panel. The source, always disconnect the source of power. Okay, disconnect the solar panel and you will do other repairs. Disconnect the load or disconnect the battery. Then the charge controller will not work, because the source of power to the charge controller is the battery. Do not switch on a solar panel on the regulator when the battery is not connected. That's why I told you we first connect coming from the loads, battery, then the solar panel is last. Once you connect the solar panel when the battery is not connected on the regulator may blow. Yeah, because for it needs the battery to be connected already. When power from the panel comes, it does the way the ICs inside here, they have a way how to do this. Then the battery will charge. But once it doesn't, it will fail. When the battery is not connected, it will fail to take some power somewhere here in the battery or to the loads, and we shall end up losing our charge controller. And this charge controller, when at night, when you connect your solar panel direct to the battery, and at night, remember at night, solar system don't work. Solar system don't work at night. They only work during day. Solar panel, I say solar panel, not system, solar panel. They only work during day when the sun is there. It doesn't work on the moon. When the moon is there, solar panel is not working. Okay, don't lie yourselves. The solar panel only work on the sun. When the sun is there, the sun rays come to the solar panel, and the solar panel will charge the battery. But at night, this battery will send back the voltages. Yet, the solar panel may get the solar cells. These cells may get fault when the battery sends back. Okay? Now, the regulator helps in limiting the voltages from the battery to go back to the panel. The regulator refuses. Okay? That's why the regulator works. It is a non-stop thing. During day it works in charging of the panel. At night it works in discharging of the battery. Okay? To the loads. Regulator works 24/7. That's why it is the heart of the system. The heart of our system. Once the heart stops, we die. Okay? Once the regulator stops, the system will die. The lights will not light, the fridge, the TVs will not light on, the battery will not charge, the solar panel will not have no use. Because this helps the battery to charge, and this at night it helps to discharge the battery, to light the battery, and to refuse the voltages at night to go back to the panel. It is done by a regulator, meaning a regulator is a full-time work, like a bulb, a security bulb. It works for the whole night, no non-stop. Now, let us come to the regulator, an inverter. When a client has components which are AC, like your TV, your fridge, your lights, your bulbs, your security lights, everything, you want your system to work on AC. You know, AC is a bit strong than DC. Okay? You apply the inverter. 12 volts from the battery. When you connect your inverter, connect the negative terminal from the inverter, a negative terminal to the negative terminal of the battery. Tighten them. Connect the positive terminal to the battery, direct to the battery. Because we need big cables to connect from the battery to the inverter. Big cables which carries enough current. Because we now here in the inverter, we have a transformer. These 12 volts we shall see when we reach on electronics, or when we reach on how to construct. We shall see if you can, we shall see also how we can construct or make our own local inverters. I will show you how to make a local inverter. This 12 volts from the battery, it has a circuit, inverter circuit, which is inside here, an inverter, okay, which converts AC to DC by using electronic components. We shall see these components when we start the electronic part. The components which are the transistors, okay, the big power transistors which are help, and the small transistor for switching on off. Okay, this DC, this circuit inside the inverter will turn this 12 volts into AC by the transistors. Those are power transistors. Now this 12 transistors, this 12 volts DC will be turned into 12 volts AC. Okay, 12 volts AC. Now this 12 volts, you know the use of a transformer. The use of a transformer, though we shall see all knowledge about transformers. Now the use of a transformer in an inverter is to transformer helps. You know, we have two types of transformers. We have a step down and a step up transformer. Now, in an inverter, remember it is 12 volts, and yet we want 120 volts, which we use in the house. It is 140 volts or 120 volts or 110 volts. We have 12 volts. The circuit, a combination of IC, transistors, capacitors, resistors, okay, which are going to make this 12 volts into DC. Now, a transformer will transform this 12 volts with 12 volts AC. It will step up. Stepping up the 12 volts into 110 or 240 volts. It steps up. It is two-sided. When you want to step down voltages, it means a transformer which steps down, which is called a step down transformer. It reduces the voltages from 220 to 12 volts. That's why this inverter, when it is an inverter charger, meaning it has a transformer which steps up. When power goes, it steps up the 12 volts into 240 volts. Then there is another transformer which steps down 220. When power comes back, it steps down 220 to 12 volts for battery to charge. Okay. Now this, we shall see how this transformer, when we reach on the transformer in electrical. Now let us finish up the solar system, and then we shall catch on the electricals. And this is how an inverter is connected. It's connected directly on the battery. It steps up the voltages from 12 to 240 or 110 or 220 volts AC voltage. AC voltage, I mean, we shall be having a live and a neutral. A live and a neutral. Sometimes we also need to have an earth. Okay, an earth, which is in electronics, we shall see in here also we shall see all metallic components need to be earthed. Okay, those are regulations in electrical. Now this inverter will produce output which is AC. AC, we shall have a neutral point, a neutral line, and a live line. Neutral line is here, and this will AC load. This indicates AC loads. As we said, AC loads are the customer's loads. That is the TVs, the sockets, the switch, the lights, the fridges. That is the loads. Those are the loads. Okay, and this is the whole system of solar installation. Even though we haven't seen the inverter, it is the next video which we are going to discuss about the inverters. After discussing the inverters, we shall be closing the solar systems. Then we look at faults on solar systems. After faults on solar systems, that's when we shall go on. We open up. Now we go on electricals. Electricals, I mean, we shall see now the part of wiring. How to wire a house, how to do all electrical, all electricians. This is yours. We shall see how to wire a switch, sockets, how to deal with the transformers, how to deal with everything in the main switch, the AC, all AC systems. Okay. Now, let us see how the solar panel can work. If you add the solar panels, please, as I told you, solar panels are the last thing to be installed. Okay? Don't forget this, because you may get burnt. You know, DC power doesn't shock, but DC power burns. Yet AC power shocks and burns. But only DC burns, but AC shocks and burns. Thank you for watching. See you in the next video about the inverters. Don't forget, because we need to know the inverters, the use of an inverter. Why do we use an inverter? Because here we can use DC loads, but some gadgets, some electronic gadgets, let us say our TVs, to work on well, they need AC. Some have no provision for DC. Okay, now we need to use AC. That's why we shall need to study also about the inverters. Next video we shall see about inverters. Don't forget, subscribe and like the physics mindset, your channel to explore on the physics, on the technology which is coming on. You know, technology without electronics, there is no technology. All technology deals with, or let us say AI, that is dealing with ICs. We shall talk about everything in electronics when we come into electronics. Just subscribe and wait for the best knowledge for you. Technology without electrical or electronic gadgets will switch off. Now, technology without solar system, all electronic or all technology will switch off. Now, with solar systems, technology will grow. With electrical installation or with electrical knowledge, technology is growing. With electronic knowledge, technology is growing more and more. Thank you for watching. See you in the next video about the inverters. Subscribe. See you there.